Welcome back to the channel. In this video we're looking at oceanography and looking at or investigating the correlation, the characteristics and links between the ocean temperature, the ocean salinity and the ocean density, and how these three parameters are going to affect the global circulation of water across the Earth's surface. This is the Earth Science Classroom. So to look at ocean density, first we got to recap what density is. Density is mass over volume, so how much stuff or material is in a given area. And the more stuff or material you put in that given area, and that area is consistent, then you're going to have more stuff squashed in or squeezed in, which will increase density. If you're going to remove the amount of material from the same amount of area or volume, then you're going to have more spaces and you have less dense material, or density will decrease. So an increase or decrease is based on how much stuff or material is in that volume of material. In this case, ocean water. Now, if the ocean water has more dissolved ions, or a change in temperature, or a change in salinity, which is the ions, then you're going to affect and change the density. So first, temperature. Temperature is in regards to the incoming solar radiation, the shortwave radiation that is absorbed by the ocean water in the top surface layer of the ocean water. Now this temperature is going to be maximized at the surface and be reduced or have less absorption of energy the deeper you go into the oceans, to a point where the sun's energy is no longer absorbed at a certain depth and temperature becomes more consistent with depth, and that is called the thermocline, that change in temperature. Now the sea surface temperature, or SST, is recorded across the whole world with various sensors and satellites, and the oceans become very accurately monitored for its temperature and changes in temperature based on season, latitude, ocean currents, and various locations around the world. Now, the surface temperature of the oceans will be higher, generally around the tropics and the equator, due to the increased concentration angle of solar radiation. Then it's going to decrease generally towards the north and south pole when you increase latitude, and you then change the angle and the concentration of that solar energy because of the Earth's spherical shape and the way that the energy is then spread over a large area, thus becoming less concentrated. So the ocean is going to reflect and absorb that energy and change its temperature based on latitude. Salinity is the percentage or amount of dissolved ions within the ocean, and this is mostly sodium chloride, about 86%. And the average of the oceans is around 35 grams per kilograms, or 3.5% to 3.55%. Now, this can fluctuate based on evaporation rates, precip rates, and inflow of fresh water from the coastlines, and obviously latitude, solar insolation, and geographic area and depth of water. However, the salinity is going to change based on these factors. So if you have the area around the equator where you have high amounts of solar radiation, higher temperatures, you have higher amounts of evaporation, thus creating a more salty and more saline ocean environment, because when you evaporate the water vapor, which is now gas in the atmosphere, does not contain any salts, and that salt is heavier and stays in the ocean water. Thus, you have an increase or buildup of salts due to increased rates of evaporation. This is only slight, but it does change the saltiness or the level of salinity within that area of the water, which is the equator. Now, this high levels of salt do occur in other areas, and it can be transferred and moved through ocean currents to areas towards the North and South Pole. Towards the North Pole, the Arctic, and the South Pole, the Antarctic. And just like in temperature, when you go down in increase in depth within the ocean, you do get a change of the salinity. So as you go down in depth, the salinity is going to reduce or decrease down to around 500 meters below the ocean surface, and then it's going to start to level off and become more consistent and actually get slightly more salty as you go down into the depths of the ocean, down into 1,000, 2,000, up down to 4,500 meters of the ocean, where it becomes more consistent. And this is called the halocline. So we have the thermocline, which is temperature, where it changes, and the halocline, where the salt level or dissolved ions changes with depth. Then we get density. Again, density is measured in grams per centimeter cubed. Now, density of the ocean, now water is 1 gram per centimeter cubed. That's regular water. When you start adding dissolved ions into that water at any temperature, you're going to add or increase its density because you've added more stuff into the same volume of water, which is the salts. The average density is around 1.025 grams per centimeter cubed. And that is going to change and fluctuate the density based on the temperature of the water and the amount of dissolved ions. So the combination of both is going to have a direct relationship or direct impact on the density of the water. So at the equator, it's going to be less dense. When the temperature gets colder towards the Arctic and Antarctic, that's where you see the greatest change in density. The density is going to increase and that water gets a lot denser, in addition to the amount of salts or dissolved ions. The change of dissolved ions or the salinity within the oceans does have an effect on density, but not as much or not as great as the change in temperature. But in combination with temperature and salinity, you get the greatest change in density, which you do find around the equator, and you do find around the Arctic and Antarctic, or the North Atlantic and the South Atlantic oceans. Now, for the vertical column of water, density does change, so you have this lower density towards the surface. But then as you go deeper down, you increase in depth, just like with the salinity and the temperature, you get this sharp change in density, which actually increases to around 1.028 grams per centimeter cubed, and then it becomes more consistent down from 1,000 meters down to about 4,000, where it stays at that 1.028 grams per centimeter cubed all the way down. So the change from that less dense surface water to the denser 1,000 meter onwards water is called the pycnocline. So pycnocline is density, halocline is salinity, and thermocline is temperature. So with all this being said, why do oceanographers and scientists care so much about ocean density? Well, it is a vital component on the circulation and movement of ocean water throughout the entire planet. So you've got the 5 ocean basins, and they are connected by the Antarctic circumpolar current around the Antarctic continent, which is the Southern Ocean, which is kind of free to move around the continent, and it connects the Pacific, the Atlantic, and the Indian. And this global movement of water, in addition to tides, in addition to climatic conditions and low pressure and high pressure, hurricanes and wind-driven currents and swells and fetch and all that stuff, the movement of the oceans is dictated by where the dense ocean is. And the dense ocean water is going to do one thing, and that is sink. And the warmer, lighter, less dense water will stay on the surface, become more heated based on latitude, and flow according to currents, and flow towards an area where you're going to have the creation of colder, denser, salty water sinking down in various locations around the world's oceans and creating this huge continuous flow of ocean water around our planet. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.